Hi. So this question, the grid shows the graph of y equal to fx. So this is some graph, some function f equal to x. And you have to find on the grid, yeah, not only find, but you have to draw the graph of y equal to minus of fx. So it can be confusing. Yeah. So before we attempt this question, I will give you the concept about this. So y equal to fx is your function, which means suppose there is some function. I can just randomly put a function like x cube minus 3x square, maybe plus 6, something randomly. I don't know how the graph will look like, but just giving an example here that for every x, there will be a value of y, right? For every x, there will be a value for y. When you put the value of x, substitute in this function, you will find a value of y. What do you get when you do y equal to minus fx? Which means this y is a different value. Yeah. So instead of calling it y equal to minus fx, maybe I will call it something else like g equal to minus fx. So what is g equal to minus fx? Isn't it simply minus y? Which means every value of x remains same, but value of y changes. And when does that happen? If you plot that on the graph, if I have a simple graph here like this, and suppose this is my graph. Yeah, suppose this is my graph. So this is y equal to fx, right? Now what happens if I keep all the x values same, but I just substitute the value of y-axis as negative y, because negative y is nothing but negative fx. And that means x is always same and y is flipping over. Flipping over means I'm going to get a reflection of this function. Ideally, maybe I should have drawn with a different color so that you can see. So let's see. It will give me the same result. Something like this. Yeah. So what does y equal to minus fx means? Y equal to minus fx simply means reflecting all the y points on x-axis, because for same value of x, for this value of x, if fx was here, y was here, the y minus y will be somewhere here. For this value, it will be somewhere here. For this value, it will be somewhere here. So it is simply the reflection on the x-axis. Yeah. Now, using this concept, you can definitely solve your problem, because what you can see is, okay, you can pick up some points where the graph is actually changing its direction, and then accordingly define the curve. So if this is the point here, you can go with the equal length. So this is at 3, go to the minus 3, and exactly same value of x, which is possibly somewhere here. So you plot a point here. This point is meeting here in the middle. So so y is equal to 2. So you go to y equal to minus 2 and somewhere here. And then similarly, this point, the stationary point nearly here, is on the number 1. So it will go on the number minus 1. So basically, your chart is going something like this here. Yeah. Similarly, for this part, pick up a point like this point is on the x-axis. So reflection will also be on the x-axis. If I put something in the middle like this point, is 1 and 2 small squares away from 1. So it will be 2 small squares away from minus 1 as well. So if I plot this graph, this will come over like something like this. Yeah, something like this. And similarly, this point, the stationary point, is nearly on just 1 square above, 1.5 square above minus 1. So this should be also 1.5 square somewhere over here. And you can continue your graph and join it like this, and then because this point is on the x-axis, so reflection is also on the x-axis, and this point is on 3, so I go to -3 just here, and it's a curve which is very similar to a straight line. So this will come out to be something like this. Yeah, you will get marks for slight if it is not exact copy. I mean, you're not supposed to draw exact copy, but as long as it is understood that this is making a reflection of this, and you can put down on your notes as well when you're drawing that y equal to minus fx is actually a reflection on the x-axis, because minus fx is minus y. This is a new function. So they've just put it same as y, and that is what confuses most of the students, because we call y equal to fx, and now we are calling y equal to minus fx. Treat this as a different function. Treat y equal to fx as your first function, and you can call another function like g is equal to minus fx, and then you can simply visualize that this is minus fx, which means this is minus y. So for the same value of x, every time I'm getting a negative value of y, which means it is a reflection on the x-axis. As simple as that. Yeah, so I'll top it up with some more knowledge here. So if I change the colors and I'll put a different one. What if the question was y equal to f of minus x instead of minus fx, right? In this case, if you will notice, you just have to change the value of x, make it negative. Yeah, make this value negative. This will give you a reflection on the y-axis now. If this was the same chart, now this chart will give you a reflection on the y-axis like this. Something like this. I mean, I'm not drawing a proper shape, but something like this. Yeah, you understand, right? So this is going to be y equal to minus fx. Sorry, f of minus x. Yeah. They can also trick you by saying what will be y of minus of f minus x. Now there are x is also negative and the function is also negative. So when that happens, first you draw f of minus x, which is a reflection of the function on the x-axis. Yeah. And then you do the reflection of this chart on the, sorry, the first one was reflection on the y-axis, yeah, because it is minus x. And then you do a reflection of this because you're doing the minus of f minus x. So reflection of this function on the x-axis. And your new function will become something like this. So y equal to minus of f minus x here. Yeah, I hope you understand this. The figures are not accurate, so it's a freehand drawing, so apologies for that. But I hope you get my point. Yeah, thank you so much. If you have any queries after this, please let me know.